And then West Coast to Spain. And so she's e-bikes. And there were friends of ours. Cheating and all that. We just let 16 grand out to application.
I can almost read. How are you?
I'm doing well. How are you?
Good. Happy New Year.
New Year.
You know, I have macular degeneration.
Oh, okay. That makes it hard to see.
I'm very tough. But I got new glasses a couple of weeks ago, so I can.
Oh, good. Okay. All right, everybody, we're going to get started. Okay, Happy New Year. Happy 2025, and welcome to the new MDAS General Meeting sessions. Just as before we get started, are there any new members or anybody first time at the meeting tonight? Okay, we've got a couple new members. Well, thank you so much for coming. If you need to use the facilities during the presentations, you just go through those doors there, and they'll be on the left. We're going to have a break in the middle for snacks in the back. Thank you, Marianne, for setting those up. They look delicious. We have a pretty exciting meeting tonight. Our main speaker has been with us several times. I'll introduce him in just a moment. Our agenda tonight includes our board election, and I want to do that real quick so we can get Jeff on the stage as soon as possible. Just a couple of updates. We have a few community outreach events coming up. The outreach coordinators can always use your help. They have several this month. Yes, so raise your hands. We've got, I think, both the Kens here. No, just, okay.
If you have any questions, come and talk to me during the break.
Okay.
We're happy to have anyone come out.
Yeah, so they need lots of help. You don't need to be trained to, like you do to bring your telescope up on Mount Diablo during the public astronomy nights. So they can always use your help. They have 4 community outreach events, MDAS.net. Make sure you go in there. All the information on volunteering and helping out is there as well. We have 2 society observing nights on the 1st and the 21st, 5 p.m., the top of the Mount Diablo Summit. Again, all the information to get up there. That's just such a privilege for our club to be able to be up there with our scopes, access to such a pristine, wonderful environment. So make sure you take advantage. Our next general meeting will be Tuesday, February 25th. Exciting for that meeting is we're going to announce our annual Joe Dish Award recipients. So it would be great if you guys can all make it and support our recipients. We have a pretty exciting presentation then. I do have some sad news I need to move on to. We're going to do the election slate before I do that. So our Zoom audience, I put a poll on there if you don't mind voting, yay or nay, on the election slate. If you vote no, you have to volunteer. Okay, so on the MDAS board election slate this year, I'm going to continue on as president. We have a vice president opening, and we're enthusiastically looking for volunteers. So if you guys want to help support the club further, just come grab me after the meeting, trip me in the hallway, give me a email, talk to any of the board or committee members. Again, you can go to mdas.net, reach out to any one of us. We can always use help to help continue this great club. For secretary, you have Moon Trask, Melinda continuing on, treasurer Beth Rainsford, and members at large would be Kent Richardson, Paul Reed, and Rich Ozer. I've got a couple chats. Let's look at it. The poll, if you go to more on your screen for those on Zoom, it will be under polls there. So you can go ahead and vote online. And so far we have 86% of people saying yes, and we've got to go. All right, whoever voted no, you got to come talk to me, you're volunteering. Okay, and in the room here, can I get a raise of hands? Does everybody approve the election slate? Okay, I've got a unanimous vote. Any nays? Anybody? No. Okay. Okay, so if you can't see the poll, we have 90%, 9 out of 10 people voted to approve the election slate online as well. So I think we're good to go. All right, thank you so much. Moving on, let me just make sure I'm ready. Okay, this is a little harder. So we lost a couple members recently, and it's kind of unexpected news. I know I had just talked with David before his passing, and all seemed well. So we've lost both David and Tom. David was a beloved, committed member of our club for many years. He served as vice president in 2020 under Steve Jacobs, and our president for the 4 years after that, and then again went into the vice president role, helping me out last year. He was very passionate and dedicated to this club and did a lot to support it behind the scenes. He will be greatly missed. Tom Boltz was a member, longtime member who joined the club and really did a lot of research, outreach for us with his telescopes. He really enjoyed the influence he had on the young people in the community through the outreach and gathering the excitement and enjoying the night sky through his community outreach. So MDAS would like to send out our sincerest condolences to both of their families. They were both great men and will be deeply missed. Did anybody want to say anything?
Well, Tom also helps out over in outreach a lot.
Yes,
Oh, yeah.
Tom was out with the outreach group a lot, so you guys, I think, knew him well. All right. With that, we're going to move on. Just pull it up one more time. Sorry, I closed my window. I got to. I am recording, thank you. I did remember finally for the first time. Okay, so our main speaker this evening is going to be Jeff Adkins. Jeff is a high school and community college astronomy teacher and longtime MDAS member. He has been providing presentations to our clubs multiple years in a row. We've really enjoyed them, and they are the highlight, I feel like, of our year because of his interactive and engaging presentations that he gives. He has inspired his students with over 35 years of experience between Deer Valley High School in Antioch and Los Baños College. He is the author of Conceptual Astronomy, as well as various other works, including a novel, a play, and several articles. He is a former NASA education ambassador and is currently lead teacher for the Academy at Deer Valley High School, for the ACE Academy at Deer Valley High School. He was the recipient of our Joe Dish Award in 2022, and he remembers arguing with Joe, a resident Big Bang basher, just like many of you. He joined MDAS because of public service ad he saw on cable TV in the 1990s. So we'd like to give Jeff as much time as possible. I'm going to get him up here right away. He's going to be presenting Aliens and the Drake Equation.
If I can figure this thing out. Okay. Everything you said is true except one thing. I have
Not sure what's going on there. You're too strong for it, too strong-willed.
You don't really need a microphone, but I'll use it.
He does not need one. All right, let's just have you use that.
Yeah.
Sorry, guys.
Okay, can you hear me? Yeah. All right, so it needs a microphone.
Zoom will need the microphone.
Oh, okay, so I'll keep this on. Zoom people, let us know if you can't hear me. I'm wearing a microphone, but we're not using the speaker here. So all of that she said was reasonably accurate, except for the fact that I did retire as the ACE Academy lead teacher. Another person, thank God, took that over for me. So I've let that go.
All right,
And,
Zoom is saying they cannot.
Okay. So I'm continuing to try to let things go. How about now?
Okay. Hopefully this will do it. Test, test. Sorry about that, no idea.
And how's the picture? They can see that okay? I think that's going to be okay for Zoom. Okay. So I'm going to need to minimize this stuff because I don't need it for me. Okay with that. And I don't need that. All right, I think that is about what I want it to look like. Okay. Right, so ready to start. I got a few students here, WAVE students. So still plugging away. This year I'm teaching 3 regular astronomy classes, 1 dual credit astronomy class after school, including the lab section for that class, 1 physics dual credit after school, including the lab section for that class, a regular physics class in high school, an honors physics class in high school, a Wednesday night class for LMC online, and a Saturday class and its lab section for LMC on Saturdays. So I think I'm teaching 12 classes when a normal person teaches 5. I'm out of my mind. It's really hard to keep track of everything, but that combination only lasts for 2 months, and then it starts to gradually ease off again till the end of the semester. So I think that's kind of like my last big push. I think I've talked myself into easing up a little bit. Anyway, on to business at hand. So we have here my presentation's about aliens, and specifically what do scientists think about aliens. There may be elements of this that you've run across here and there. I'm sure many of you run into the Drake equation from time to time. So I'll give you as much new information as I can. Maybe there might be a thing or two here you haven't seen before. So the questions I intend to try to answer: do aliens exist? How many of them are there in the Milky Way and the universe? Have they been here? Are they here now? So I'll be upfront with you. I'm essentially a professional skeptic. I think a good scientist has to be an open-minded skeptic. You're willing to listen to any idea, but changing my mind is difficult. You need to present, as Sagan said, extraordinary claims require extraordinary evidence. So on the one hand, you think, well, there's a very credible guy who's telling this amazing story. Maybe he was abducted by aliens or not. But what's the simplest explanation? Aliens broke all the laws of physics and somehow found us, or dude over here is making up a story. So you kind of, that's kind of my skeptical attitude. If you want me to buy into your story, there's an alien here, sit him on the desk, let me shake his hand. Then I'll start to talk to you, maybe perhaps I'll change my mind. So I am open-minded. I could be wrong, I admit it. But on the other hand, changing my mind is not a simple thing. It takes some effort for that. I'm not saying everybody in the world has to be an open-minded skeptic. As we all well know, pundits and politicians seldom admit they're wrong. But a scientist has to, when confronted with evidence that's incontrovertible in front of your face, you have to give yourself permission, like Kepler did, to say, you know what, maybe we were wrong about this all along and we have to change our minds. I haven't yet seen that evidence, but I have seen some interesting things, so I'm going to share those with you in this little presentation. All right, so let's see. First of all, usually you tell this long story when you do these kinds of things, and at the end you get to the punchline, and you say, here's the conclusion. I'm going to tell the story backwards. I'm starting with the punchline, then I'm going to backfill it and tell you all the reasons why I think it's correct. So this slide basically provides you with the scientist's attitude about aliens. We do have the search for extraterrestrial intelligence, so that means that there are at least some people who think the odds that aliens exist is not zero. So it's worth some time to look. But if you were to ask an astronomer, do they think they're aliens, they'll give you what sounds like two contradictory answers, but they're actually very consistent. Number one, it's a great big universe. If life is natural at all, there's probably lots and lots of aliens scattered throughout the universe and perhaps even in the Milky Way. So if you ask your typical astronomer, do you think that aliens exist? They're going to say, well, yeah, I do. I think there probably are lots of aliens in the universe. Then if you ask them a related question, well, have those aliens ever been to the Earth? They're going to say, absolutely not. They've never found us because we're so hard to find. We're very small in the universe. And these are not contradictory answers. It's based on the same fundamental fact. The universe is huge, so there's lots of chances for life to develop it. The universe is huge, which means it's really hard to find us. And those are actually consistent answers. So let's dig into that a little bit. Here's a slide I developed as part of another PowerPoint I'm not sharing with you tonight, but it's about the scale of the universe. And I carefully constructed this slide to illustrate the issue. I actually got this one, was published in like Education Week. They pushed this picture out in an article to try to explain how teachers deal with claims about UFOs. So they took this slide and put it in a magazine. What I did here was I said, okay, your typical projector, like this one, has about 1,000 pixels wide, give or take a little bit. And the Milky Way, as we all probably know, is about 100,000 light years wide. So if you take 100,000 light years and divide by 1,000 pixels, that means every pixel in this picture is about 100 light years wide. Simple division, right? So 100 light years was represented by every single individual little pixel that you can see here. And if you walked up here with me, you'd see that the dotted I on the word pixel actually consists of about 4 pixels, give or take. So what this picture represents to us in our search for aliens is this. We first developed radio a little more than 100 years ago. And radio powerful enough to reach out into the universe that someone with a ridiculously large antenna could maybe overhear, eavesdrop on us and know that we are here. They would have to be within 100 light years of the Earth for that radio signal to have run into them so that they know that we are here. Furthermore, they'd have to be within 50 light years of us for them to have heard our signal and decided to reply and then answered us so that that signal had 50 years to get back to us. And today we would discover, oh, there are some aliens within 50 light years and they're answering us and trying to contact us. So that one pixel that's inside that dotted eye, about a quarter of the size of the dot you can see there, is 100 light years across, which means that if the aliens are going to be there and hear us and have some hope of knowing that we are here so that they can take time out of their busy lives to somehow make the enormous journey using technology far beyond our imagination to come to our planet and annoy our Air Force and knock down our corn in circles, kidnap our women, and shoot down things, fly on the East Coast and disguise themselves as drones. If they're going to do all of those things to us, they have to live inside of one pixel of this picture, else they do not know we're here. So there could be lots of aliens in the Milky Way. Take a handful of salt. Salt crystals are aliens, and you fling it at the screen, and maybe it sticks to the screen. And the odds of a salt crystal landing on our pixel are actually fairly low, even if there's lots of aliens that exist in the Milky Way. They'd have to be right in our adjacent pixel for them to hear us. 50 light years in each direction is 100 light years wide. So if they're in the pixel with us, we could have heard them. If they're in the adjacent pixel, they could have heard us, but we haven't heard them reply yet. So this gives you the scale of the problem, and it really defines the astronomer's attitude towards aliens. It's a big galaxy. There's lots of room in it. If life is natural, there could be maybe, well, a whole bunch of planets with aliens on them. But what are the odds that one of them wants to talk to us, has the means to do it, and sends us a message, or even that two of them are talking to each other and we happen to be in the middle? What are the odds that they're going to be close enough to us that they're even talking to us in particular, that they care that we are here, or that they're even just talking to someone else and don't even notice that they're letting some, angry monkeys on a dirt ball eavesdrop in their conversations? So I feel pretty comfortable about that conclusion. And when people say, well, maybe they have technology far beyond anything humans can imagine. We don't know everything. And, well, okay, if you're going to talk about magic, okay, fine. You first accept that there's magical technology far beyond the laws of physics. So you wave the magic wand and anything can happen. So that, again, is an extraordinary claim, and I have yet to see the extraordinary evidence that goes along with it. So the skeptical side of me says, yeah, okay. I'd read that in a book or watch it in a movie. I have a strong suspension of disbelief. I don't start picking on the movie till I leave. While I'm watching it, I'm like, yeah, go get them. I'm totally into it. I believe, the Iron Man can get hit and knock up against the wall and not shatter all of his bones. It's isn't like a hamster in a can shaking it violently. I can let it go. He's got a suit, he's got a suit. I can believe it until the movie's over. And then I go, dang, yeah, Iron Man. But you know what? I'll say this about Iron Man. At least I kind of get the boot jets. Okay, I can see that he could maybe fly, but I honestly don't understand Superman. No one has ever explained to me what is the mechanism that makes him go. He just goes. We accept that he goes, but there's no physics mechanism for it, right? He doesn't have the ability to bend space-time. He doesn't have a warp drive built into his boots or something. It's he just does it, right? So I'm a little bit on the Iron Man camp, a little bit leaning that way, but still, the first hard punch and the dude's done. So, I'm a skeptic after the movie's over. During the movie, I'll just enjoy it and watch it like anybody else. Anyway, so like I say, this is sort of the conclusion of the talk. I'm done. I'll see you later. That's what we think. But there's, of course, how we like to say, a small non-zero chance that we are wrong. Maybe there are aliens. Maybe they are nearby. Maybe they've been here. We could be wrong. Science has been wrong in the past. We could be wrong. If you're an honest scientist, you admit, I don't know everything. No scientist knows everything. We could be wrong. So if we're wrong, maybe it's worth some time to look. So this is about looking. Yes, sir. Did I accidentally turn it off? I didn't touch the switch. Test, test. I don't think the mic is working. I'm not. Oh, I'm getting echo or something.
Hello? Oh, there we go. How many star systems are within 50 light year radius?
How many star systems are what?
Within the radius
Oh,
of the
hundreds.
pixel?
A few thousand. I think.
Within,
Yeah,
in the
thousands,
vicinity.
not millions. So yeah, within the 100 light year, thousands, I think. If you count all the little ones too. All right, so let's talk for a minute about them coming here. Here's the issue. You see a lot of reports lately about, the drones on the East Coast. And there's been a flurry in the past 5 or 6 years of pilots and Air Force people releasing secret reports, and they saw these, the people are testifying to Congress, yeah, the aliens are here, there's a secret, the government, you hear a lot about this, right? So the thing about that is, there might be something to all of that. And certainly there's a distinction here. If you have an unidentified aerial phenomenon or an unidentified flying object, there's lots of things that I've seen in the sky that I've seen stuff I didn't understand, but I didn't jump to the conclusion.
Zoom's saying they're not hearing you.
Oh, okay.
Oh,
They're not hearing me.
okay, sorry, I'll have to turn it back up.
That's okay. So maybe I just should hold it farther away when you turn it back up. Testing 1, 2, 3. All right, Zoom people, can you hear me?
Sorry about all the technical issues. I thought I had them figured out.
All right. So my point is, it's really easy to see a thing you don't understand or make up a story. But what's difficult is explaining it. It takes time and effort and experiments and trials to explain an unidentified object. And sometimes we can explain them. I can't say that we can explain all the things that people have seen, but then again, it takes a lot longer to investigate these claims than it does to just listen to story after story after story. So I'm just going to share with you an example of one that was that came up in the news a few years ago, and it was widely circulated as yet another UFO video that the experts couldn't explain, and the pilots in the Air Force were claiming there's a mysterious thing, we don't understand what it is, and maybe it's an alien, right? So the video, you can look it up at the YouTube link down below, showed a triangular spaceship of some sort chasing our fighter jets and making impossible right-angle maneuvers and doing things that defied the laws of physics. And so the pilot said, we saw it happening. It was right there on our video screen following us behind us, and we have no idea what that was. And we double and triple checked it, and it just seems impossible. It's got to be some kind of mysterious technology. So in the spirit of doing a full investigation, a group got together and purchased a surplus camera identical to the one that's on the fighter jet, and took it into a warehouse and set up a distant bright light in it and did some experiments with the camera. And long story short, they discovered the triangular spaceship was being created by the triangular aperture inside the camera, and it was reflecting the light inside the lens. And when the camera would move, the triangle would do an impossible maneuver. So the entire thing was recreatable. They could create the event and duplicate what was seen in the recordings with a distant bright light shining in a triangular aperture. So they explained this one. This one got explained. Does that mean that they're all explained? No. But you got to be willing to give people the time, and it takes money to do such a thing, and give them time to investigate it thoroughly. It works better if you can reproduce it. So I'm not saying that every UFO sighting is explainable, but a lot of them are. And here's the way this thing works. It's kind of like the same thing. You remember how many times you heard a news article says that the Earth is going to be hit by a meteor in 2036, right? So this is the same kind of thing. Let me explain how that works. Somebody discovers a new asteroid, a little tiny rock that's big enough to hurt us. They plot its orbit, and the Earth is here, and the asteroid's in a circle this big. So there's like a 10% chance it's going to hit us. The news comes out, asteroid might hit us in 2036, and everybody starts talking about it. Then they do a revised orbit, they get better data, and they make the circle a bit smaller, and the Earth is still in the circle, so the news report comes out. The odds of it hitting us are increasing. We're all in danger. And so everybody reads that, and we all have that stuck in the back of our minds, and then they do a better orbit, and now they've got it refined down to this circle, and the Earth is over here. So all of us find out there's no chance that the asteroid's going to hit the Earth, and that is not interesting. So it doesn't make a news. So the public is left with this lingering suspicion that someone's not telling them that we're going to be hit by a meteor because they're keeping it secret somehow for some reason. That's because it doesn't earn clicks to explain a thing. So you're not going to find many people referring to this explanation. You're going to find the mystery is exciting to wonder about, but the explanation does exist. It's just not as popular. Anyway, so that's kind of what I have to say about UFOs. You got to take them case by case by case, and no, I'm not an expert on all the different sightings, but I do know that in many cases we have explained them, and many others we have not yet done it because the time and the money has not been invested to do so, or maybe we just don't have enough data to pursue it further. Yes, sir.
Are you familiar with the gimbal incident?
Tell me about it.
So in the early 2000s, can you hear me now?
Yeah.
Okay. Sometime in the early to mid 2000s, there were objects that were picked up by an aircraft carrier radar. They flushed out 2 fighter jets. Each fighter jet had 3 personnel on board. What they encountered is what they called a tic tac. It was a 40-foot long object that was cylindrical, and they engaged it. This object went 60,000 feet from the sea level. First, they tracked it on their targeting radar. It shook the targeting radar. You're familiar with how FA-18 targeting radar is? I mean, usually when you lock on something, you can't, it's hard to unlock it. Well, this object was able to, outmaneuver the targeting radar. But to make a long story short, it went from just above the surface of the sea to 60,000 feet in 2.8 seconds. And this was recorded by both pilots. Everybody, all 6 personnel on that aircraft. It then returned down again. No sonic boom, nothing.
Did they see it with their eyes?
They saw it with their eyes, and they tracked it with their instruments. There is data that's been released to the public, and you can find this. You can look up the gimbal incident, and you can find that one too.
Oh, I've opened a can of worms now.
Yeah.
Okay, we're gonna just take a couple questions or comments. Okay.
There's a recent NOVA that just came out in the last 1 or 2 episodes that covered both those incidents, the gimbal incident and the Tic Tac incident. And the gimbal incident was similar to this one. The way the explanation was that the way that the camera, the infrared camera was rotating, made the object appear to be rotating. And the Tic Tac incident, I don't remember the exact explanation, but there was an explanation for that one too. So I suggest you.
What's the explanation?
Well, I watched it just recently, but I was a little bit sleepy, so I don't remember exactly the explanation. But they covered both of those incidents, the gimbal incident and the Tic Tac incident. So I suggest you watch that and maybe you have some new information.
Okay, one more comment, and then we'll let Jeff move on. No, okay.
Just watch the NOVA episode.
Nova episode. Okay.
Okay, so who is NOVA and who did the research?
Okay, NOVA is a show on PBS, Public Broadcasting Service. They have the person who did the research on the show.
Who is the person?
I don't remember their name, but the first thing they point out is that almost all these recordings are done with infrared cameras. And that creates a huge distortion of what you're looking at.
I agree with you.
Yeah, okay. But the bottom line of this is they plotted out the motion the camera makes as it moves in an arc, as it's tracking objects, and
About the targeting radar?
the filming radar, the filming camera. And it moved in exactly the same arc that the Tic Tac was moving in, which tells you that, unless you believe in unbelievable coincidences, that this is an artifact of the camera system problem.
This is no
Just-
artifact.
just-
They had 6 highly trained personnel vouch on their sightings. They have this on instruments.
Let me tell you what I think
Okay,
that
we're gonna let
means.
Jeff continue.
Here's what that means. You have reputable people, experienced people, telling you about something that is fantastically unusual and hard to explain. Then what that triggers to me as a scientist is, I identify that needs more study. So my point is not that I believe it or disbelieve it, but it's enough, like you get somebody who has that kind of a reputation, who's that kind of experience, more than I do, then I would say, okay, let's dig into that now. Let's just dedicate some resources to it and find out what's going on. So I just have to be willing to say, it does take time, and there are not enough of us who are good at this to investigate every claim. Just like the meteor story, it's going to take a while to catch up with it, and it may actually be found out, and you might not hear about it because it's not exciting. It's exciting to wonder that there's something we don't understand. It's not exciting to find out your camera's malfunctioning. So I'm not saying that applies to this example, but I'm just saying this would trigger me wanting to spend the resources to dig into it some more. Because those people's reputations and their experience does count for something, but as a skeptic, I remain unconvinced. Is it possible that this is a thing that breaks all the known laws of physics? Or is there something that's possibly a technological error? In my mind, that's the simpler explanation, even though I don't know what it is. So I can't claim that I know the answer to that, but I can also say that I am, as of yet, unconvinced, because that's still a possibility. That's my attitude towards it. All right. Well, anyway, honestly, that's all I have to say about that. So now let's talk about what scientists who are working as astronomers, and this is the Astronomical Society, what do they think about aliens? So the first serious work to try to estimate whether or not aliens exist and how many there are is done by, Frank Drake. And of course, Frank Drake's famous equation is based on earlier model of how to solve problems created by Enrico Fermi. Enrico Fermi, the nuclear physicist, did actually, super genius guy, occasionally teach an introductory science class. So you can imagine walking into a class with Enrico Fermi as your teacher, and it's like this high-powered Nobel Prize-winning genius, and he's trying to talk to freshmen and teach them something. So the first day of class, the legend is, he would have the kids walk into this first-year class and say, okay, get out a piece of paper, and now tell me how many piano tuners live in Chicago. And this is all before the internet, and there's no phones, right? There's no phony people looking it up on the Google. They just saying, how am I supposed to know that? He says, you're not supposed to know, you're supposed to figure it out. So he was training them, what would you need to know in order to estimate how many piano tuners live in Chicago? So some kid says, you need to know how many people live in Chicago. All right, well, I don't know, how many is that, like 3 million or something? All right, and the second thing is, how many families is that? How many people are in a family? Some kid says, 3.5, 4. So you divide the population by 4, you got families. How many families own a piano? And the kids didn't know, so we're going to do that question right here. In your home right now, today, 2025, how many of you have like an actual non-electronic, keyboard-based piano somewhere in your house, right? Now, we're a skewed sample because we're older, but then if you take that proportion of the population and apply it to that, then you say, okay, now we have an estimate for how many pianos are built into Chicago. Then you say, well, how long does it take to tune one? And how often do you tune it? And how many can a piano tuner tune in a day? And you take all these numbers and you multiply them out. And you come up with, I think the original story says he came up with an answer around 30. Now, is it right? Even if you look in the phone book, because back then they had these books with phone numbers in them. And they had yellow pages where people advertised, and you could look at the piano tuner section and count them. Even if you had such a book, there might be people who don't advertise in the yellow pages. You would not be able to know that answer. Even if you tried to ask everybody in Chicago one at a time, by the time you got to the end of the list, some of them would have died. Others would have moved in. So you'd never really know if you had the right answer, but you could get a really good idea of what you might say an educated guess that's a reasonable estimate, right? So Fermi pointed out to his students, it's really not about knowing the exact right answer. It's about figuring out what you need to know and then finding ways to get those numbers. we can refine them as we learn more, we can get a better and better estimate. But honestly, we probably never really know the exact number, but we can get pretty close. So using this kind of logic, Frank Drake wrote this equation, which you may have seen before. Raise your hand if you've ever seen the Drake equation. Yeah, so it's pretty famous. And basically, you just take all of these numbers and you multiply them all together, and out pops a number. The number represents how many civilizations, alien civilizations, are in the Milky Way, just the Milky Way, right now. So we're not taking into account the lifetime of the galaxy and how many that might have existed and don't exist anymore, but we're kind of talking about now. So each of these things has a definition. I have a slide for each one, and what I'm basically going to do is I went through and looked up the answer for each number. Frank did it too, but back in the 1960s when he wrote the equation, he didn't know all the numbers. So here is Frank's original estimate. Now this is, a lot of things are very uncertain, so you can't express it as a single estimate. You get a range. It could be this small, it could be this big. So you wind up with two estimates. The pessimistic estimate, where you put all the low estimates in, and the optimistic estimate, where you put all the big numbers in. So we're still doing it that way today. If you take all of Frank's numbers, for example, the fraction of planets that have, stars that have planets, he didn't know that exoplanets existed. We didn't discover the first one until the 90s. He had to guess. He guessed it's maybe 0.2 to 0.5 planets per star. We now know that's more than that. But using all of his educated guesses and, pessimistic and optimistic numbers, his range went from 20 at a minimum to 50 million at a maximum. And really, the answer just depends, as it turns out, primarily on whether you're a pessimist and an optimist. And it turns out the most thing that determines your answer is your estimate of how long the civilization will last before it kills itself off. Almost everything else sort of multiplies out to be a small number, and you multiply it by the lifetime of the civilization, and that's your answer. So that last number is really the critical one. Anyway, those are Frank's answers. So I says to myself, all right, we know more than Frank did. So let's look up these answers and see if we know more. Can we get a better answer today? So I started looking them up. Here they are. This citation I found from 2010, and people are still quoting it. So even though it's a little old, they haven't really revised it much. The total star formation rate is 0.68 to 1.45 M circle with a dot. As you may know, that means masses of the sun. So basically, about one star a year altogether being created in the Milky Way. That's called our star. How fast does the Milky Way make stars? About one a year total, give or take a little bit. I do have the references. So I will confess to cheating by reading the Wikipedia article. But what I did do, and I tell my students to do, it's okay to read Wikipedia. Just your English teachers tell you don't quote it because it's not the primary reference. Not because people lie in it, but they do. But in physical science, they generally don't. It's pretty accurate, but you're still not supposed to quote a secondary source. You cheat by looking at Wikipedia's references and you read them yourself. That's okay. Nobody objects to that. So I did that too. I clicked on their links and references and looked up the papers. So just to verify they're saying what they say they're saying. So anyway, there's your reference for that one. What about the next number is the fraction of those stars that have planets. Now, as I said, we kind of know more now than we did back in the day. So another often quoted thing about using gravitational microlensing to get an estimate of the number of stars with planets. The survey they did estimated 1.6 planets per star. Now, my opinion is, if you look at the ways that exoplanets are discovered, the transit method, the Doppler wobble, and the microlensing, the direct imaging, and you count them all up and everything, there's a bias in the data. We are better at detecting giant planets, because when they go in front of the star, they block more light. We're better at detecting planets close to the sun because they go in front of the sun more often, and we've only been doing this since the 90s. What if a planet like Neptune, 160 years ago around the sun, has just never bothered to go in front of the sun yet? So we're not good at detecting distant planets, and we're not good at detecting tiny planets. The smallest exoplanet discovered so far is, I think, about 3 or 4 times the size of the moon. It's called Dragour. Very tiny little thing, but we don't detect many of those. We're not good at it. So in my considered opinion, whatever number we get from counting real exoplanets is probably an underestimate. We're undercounting the number of planets because we're not able to statistically verify that the little ones and the distant ones exist. Maybe you've heard of the whole hot Jupiter mystery. Why are there hot Jupiters really close to the sun? We're good at detecting those because they're big, they're right next to the sun, they block a lot of light. We don't know why they exist, but we can detect them really well. So there's a bias in our data, and in my opinion, we're undercounting. But we got to have a number, so we'll use 1.6. There's a number, and there's your reference for that. Now, N sub E is the number of those planets that might support life, and this is somewhat debatable because, here's where we start having problems with our statistics because we only have the one data point we know about our solar system. So we have to start talking about the Goldilocks Zone. So here you have an illustration of the Goldilocks Zone for several real exoplanet systems. The green zone shows where you could put a planet and liquid water could still exist on its surface. So in our solar system, we generally consider the Goldilocks Zone, not too hot, not too cold, but just right, to run from Venus to Mars. And you should object. You can't live on Venus, it's too hot. You can't live on Mars, it's too cold. That's not what we mean. What we mean is we put the Earth where Venus is. If there was a duplicate of Earth where Venus is, yes, it would be hotter. It would not have a runaway greenhouse effect because our atmosphere is thinner than Venus's. But it would be much hotter, our deserts would be bare, maybe the polar caps would melt, but there would probably be habitable areas still on Earth if we were where Venus is. So it's in the Goldilocks zone. If we put Earth where Mars is, we have a thicker atmosphere than Mars. We trap some of the heat. We'd be colder. The polar caps would be bigger. Maybe we'd lose all the deserts and the equatorial regions would be green and lush. But there'd still be places on Earth where you could live. So we would generally estimate the Goldilocks zone for our solar system to run from Venus to Mars. Closer than that, too hot. Farther than that, too cold. Now, one of the systems that has the most planets in the Goldilocks zone, illustrated at the bottom there, is the TRAPPIST-1 system you might have heard of, that has the largest number of Earth-like exoplanets discovered in the same system so far. 1, 2, 3, 4, 5, 6, 7 Earth-like planets, meaning that it's made of rock, it has a surface, there's maybe an atmosphere. 7 planets that are not gas giants that are orbiting this one system. That's the record for the number of Earth-like planets that have been discovered around one star so far. Of those planets, it is estimated that 3 of them are in its Goldilocks zone. So that would be an estimate of 3. Now, I read a reference that said data from Kepler, the exoplanet space probe, says there's an estimate of 3 to 5, including the planets that we're not good at detecting, 3 to 5 Earth-like planets in the Goldilocks zone per star. To me, feels a little high, but then again, they're probably making some estimates about the planets we can't actually detect. But there's a number, and I don't have the link there, but it exists. So there's a reference that says that you can use that as an estimate. So 3 would be the pessimistic number, 5 the optimistic number. And for me, I kind of like to say, well, we only know about the one system. And in our system, okay, 3. There's 3, it could be 3 planets in the zone. Doesn't mean they have life, but they could. So I can kind of see a 3 for our system. Anyway, moving on. What about other stars? Yes, sir.
There is a great lecture about those, what do you call it? Where they all those stars. One star with it's a trapezium?
TRAPPIST-1.
It's a quite new lecture that you can find. It's on a British website, but I'm sure she's an American researcher, but I can't remember the names.
Well, that's why we have the Google. I bet we could find it if we look.
Right, yeah.
Let's consider other stars for a minute. What about their Goldilocks zones? Do we search every star that exists for these Earth-like planets and life-bearing planets? Consider a red dwarf. Because it's colder, the zone that you could put a planet in where the temperature is right is very narrow. So, and in favor of the red dwarf stars, you may know this, they last a really long time. The estimated lifetime of a red dwarf can exceed the age of the universe. Some of them have been around since they were first formed and haven't burned out yet. They burn very slowly and quietly. So that's good. That's good for developing life. It lasts a long time. But what's bad is, what are the odds that there's a planet right in that zone and it stays there? No other planet perturbs its orbit and moves it away. So you need a planet in that narrow band, and it has to stay there. Acting against red dwarfs is the recent discovery that they tend to have a lot of flares. So a lot of flares going off in the red dwarfs that would bathe the planets up close in radiation, sort of like trying to orbit in Jupiter's radiation belt. So large complex molecules will be broken apart by such radiation, and that means not such a great place to find life. Okay, well, what if we have a bigger Goldilocks zone around a blue giant star? It has a huge, wide Goldilocks zone. Lots of planets could fit in there. The odds of finding one and one staying there are much higher. That's good, but as you may know, blue supergiant stars only last about 500 million years. So while you might have a planet there, and it might even have water on it, the odds of it developing life the way the Earth did, in the time frame that the Earth did, it just doesn't last long enough. So using this kind of logic, we come to the conclusion that our planets that we should focus our attention to are ones like ours. We're looking for sun-like stars, to have Earth-like planets, to be like us. As long as we're talking about life as we know it and not some exotic thing made of silicon and other things that are just, imaginary. But, talking about things like us, it really should be around an Earth-like star, a sun-like star. So anyway, we have an estimate for that number. The fraction of planets that go on to develop life, again, here's where the whole system starts to break down. We only have you can't do statistics on one example. So now we're guessing, right? We're really guessing. But if you look at the Earth, the history of development of life on the Earth, once the conditions allowed it, it didn't spend very much time lifeless compared to, life developed pretty quick. Not intelligent life, but some kind of reproducing life developed fairly quickly after the Earth conditions allowed it. So if that's an indication that life is natural, it could be relatively quick and kind of automatic. Once everything that needs to be in place is in place, it just sort of happens. So that would be the optimistic interpretation. So any planet essentially that could develop life will develop life if all the pieces, parts that you need are there. And then again, if you're a pessimist, you say there's lots of planets that have water on it, but the water doesn't move around, it's frozen, or the water's in a radiation zone, so the molecules can't form, so it never develops life. But if you're an optimist, you pretty much say, okay, any planet that could develop life will develop life, and you call the number 1. It's 100% of them eventually will. Now, what about the fraction that develops intelligent life? Once again, one example does not a statistical argument make. Now, Pascal Lee of the SETI Institute has argued that the value of the fraction of planets that have intelligent life is very small, and essentially he's going to repeat Carl Sagan's argument using the cosmic calendar. I wonder how many of you have heard of that? Cosmic calendar? So I guess I get something to talk about. I can talk about the cosmic calendar. So this argument is going to be based on the idea that Earth had life for a long time, but the intelligent part of it was not very long. Didn't last long compared to the lifetime of the Earth. So in his old TV show Cosmos, Carl Sagan presented the cosmic calendar, which I have copied here for you. So in this idea, we take the entire history of the Earth and compress it to 1 year. So the Big Bang happened on January the 1st. Today is December 31st at midnight. So if you make the spacing of the ages of the Earth proportional to the length of a year, you can lay out when things happened. For example, the Big Bang happened in January. The Milky Way formed in May. So we didn't have the Earth or the Sun until then. It says the Sun, here the solar system, was formed around September, and not long after that, oxygen began being generated by photosynthesis in October. So something was making oxygen. As you know, oxygen does not occur naturally in planetary atmospheres because it's so reactive. You have to replace it all the time because it reacts with stuff. Like on Mars, all the oxygen's in rusted rocks. There's no free oxygen in what atmosphere it has left. And planets that have free oxygen, it'll react and you have to replenish it or you don't have any oxygen. So if you look at the calendar here, in November, we start getting cells, not till December till we get multicellular life. And then all the action in this bottom part of the chart is in December. So if you look at some interesting milestones, Pangea starts to break up on December 24th. Dinosaurs began around December 25th. Mammals started on the 26th. Birds And surprisingly, flowers didn't exist until the 28th. Tyrannosaurus Rex was on the 29th. The big meteor that landed in the Gulf of whatever the hell we're calling that this week, that landed on December the 30th. And then all the stuff that involves us is on the last day. So starting from this point on is the last day of the cosmic calendar. So modern anatomical humans started to walk upright at 9:25 p.m. Human brain begins getting bigger at 10:30 p.m. Modern humans that you would recognize at 11:52 p.m. People spread all over the planet from 11:56 to 11:59, and now in the last minute of the last hour of the last day, we start to have intelligent humans who can communicate with each other, but only on the earth. So first cave paintings, 50 seconds to midnight. Egyptian civilization around 19 seconds to midnight. Agriculture, 20 seconds to midnight. Written records begin about 12 seconds to midnight. Christ was born 4 seconds to midnight. Muhammad, 3 seconds. Columbus arrived in America a little bit, slightly more than 1.2 seconds ago. And then midnight is here today. So here's the question. Of that entire interval of time, what fraction of the Earth's existence did life exist? Most of it. Aliens that come to Earth looking for life are going to find some. There might be plants, it might be dinosaurs they're talking to, a bunch of mammals running around, stuff like that. And they say hello, and the dinosaurs go, And they can't talk. They're not intelligent. They have no message to convey. Only in the last few seconds of the cosmic calendar could the aliens talk to us and expect us to reply, even in spoken words, let alone radio, right? So this is an argument saying the fraction of them that are intelligent compared to the fraction of planets that have life should be a relatively very tiny number. Now again, statistics is a difficult argument when you have only one example. Maybe there are planets where intelligent life developed much more rapidly. Maybe there are planets that are much older than the Earth and never developed intelligent life until we get the technological ability to detect life on other planets and see if it's intelligent. We can't form any statistics. But I would remind you that most of us were alive when the first exoplanet was discovered. And I remember I started teaching before the first exoplanet was discovered. And I was telling my students, we may never know if there are other planets in other solar systems. We don't know. We can't detect them. I thought back in the early 80s that we'd have to send a space probe to Alpha Centauri to see the planets. I had no idea that digital cameras would evolve to the point where we could actually see and detect reliably exoplanets. So in another generation, when these young people grow up and they're my age, they'll be telling their students or their friends, oh yeah, I remember when we first found life on an exoplanet. We don't know what kind of life it is, but we know there's life there because of X, Y, and Z. Our technology has advanced. You see what I'm saying? So maybe we'll get to the point where we have some statistics, but that day is not today. So what we have now is just a relatively uneducated guess. But I think you can see if we're typical at all, and the Copernican principle tells us that every time we think we're special, it turns out we're not. So if that's true for life, then this is pretty common, and therefore the conclusion that the fraction of planets with intelligent life being small is probably more true than false. Right? You guys know the Copernican principle, right? Every time we think we're special, we're in the center of the universe, turns out we're not. We're not the center of the solar system. Our solar system is not the center of the universe. The Milky Way is not the whole universe. We live in a suburb of it, right? So I tell my students from Antioch, Earth in the Milky Way is like Antioch to San Francisco. You live out near the edge. No one has to come out to where you are because it's too far away from everything. So, that's where we live, So, every time we think we're important, turns out we're not. It looks like all the galaxies are moving away from us in the Big Bang, but it turns out every other galaxy sees the same thing. So if we're not special in that way, that applies to this as well. So this would be considered to be, kind of an average situation. And again, hard to claim statistics when you only have one data point. Anyway, that's the argument about the fraction of planets with life. Let's see, where am I over here? Okay, here. Fraction willing and able to communicate. So you have life, and it's able to talk.
Oh, hi, Jeff. This is real good. I have one question. Have you looked at the work of Jonathan Chiang, professor at NASA?
I have not.
Okay, him and a couple of other professors and some Caltech students, they took what you're talking about and added some additional variables. One of them was looking at the propensity for Earth-like planets to be near stars that are similar to our sun, and those would be concentrated towards the center of our galaxy, maybe anywhere from 8 to 15,000 light years from the center. So we're basically at the edge of the outer ring, and we probably, what you showed on that chart shows we're probably sitting somewhere around 13 billion years when all that development took place, 13.5. So using that data point of finding the large number of sun-like stars towards the center of our galaxy would probably change. That could be a statistical model that can give different results.
Oh, yeah, I mean, everybody who does this makes their own set of assumptions, and they go through and make their best estimate, and there's all kinds of different people's versions of the Drake equation. So there is no one official best answer. So there's been who knows how many articles written about that. I would point this out, though. If you live near the center, I did a study once of the number of type 1 supernovas in the Andromeda galaxy, and it turns out they're way more common when you're near the center because there's so many more stars. So actually it might be safer to live out on the edge because the supernova rate is a lot lower. If Betelgeuse is 500 light years away from us, it would have an effect on us when it goes. We're going to notice. It won't kill us all dead, but we're going to notice, right? So if there are a lot more stars in your neighborhood, you're higher at risk. So maybe it would be better to look at stars out in the outer rim and not in the galactic center, because there might be more planets, but they're also at higher risk. And there's the whole active galactic nucleus thing, but that doesn't really apply to us.
No, I understand what you're saying. I think what Jonathan Chiang and his other professors' research indicated was that the possibility of life occurring within that 15,000 light year band from the center is significantly high because of the number of stars that are similar to our sun.
Sure. Well, there's more stars, so the odds are higher for that.
Yeah. So he's thinking that, and he has a write-up on this. I'll give it to you after the meeting. It's very interesting. It's actually intriguing.
Send it off to me.
Yep, I will. Anyway, carry on.
Okay, so fraction willing and able to communicate. You've got to be able to, if you want us to detect you, we're counting alien civilizations, we got to be able to hear them. They got to be able to hear us. You keep hearing a lot about 21 centimeter radiation. That's a wavelength that can penetrate dust and go through the dark nebulas and make it through the arms. So even though it's a primitive technology, it might be selected by aliens because they would know, like we do, that it would penetrate those dust clouds, and a signal in it is common, and we'd be able to pick it up. So there are physical reasons why people look at that wavelength, but we'll talk about wavelengths in a little bit. In terms of willing to communicate, I want you to consider the case of China. Until recently, historically, they kept closed borders. You might remember, if you've had world history, China used to have the world's largest sailing fleet, and they became paranoid about contamination of their culture, so they burned all their boats and stopped exploring and brought everybody home because they didn't want those contaminations to. They built a Great Wall, for gosh sakes, to keep people out so that they didn't want to communicate with the rest of the world. They wanted to be isolated until relatively recently, when all of a sudden they've changed their minds. So there could be civilizations that have just decided we really don't want to talk to the rest of the universe. And in fact, that is the plot of the recent book and movie, The Three Body Problem, where civilizations decide, yeah, I don't want to talk to the rest of the universe because you guys are dangerous. So civilization would be advised, don't advertise yourself. What if some malevolent force comes looking for you because you won't shut up? So Stephen Hawking argues that maybe we should just not have any more radio. We shouldn't send any signals that can penetrate the atmosphere for that same reason. Another issue is that although we keep talking about that, the aliens could be within 50 light years, you'd have to have a gigantic dish to pick up our puny signals that we're not aiming at you on purpose. Jill Tarter of the SETI Institute estimates the radio telescopes that we own on Earth now could only pick up our TV shows and radio shows within a light year. Beyond a light year, the signal's too weak, and we'd have to have much, much larger dishes to pick up the signals that we claim the aliens are listening to. So it's even worse than I said before. Unless they're making a deliberate effort to listen with gigantic radio dishes that can focus the energy large enough to hear the signal, they wouldn't, again, know that we're here. So anyway, it's a guess. Pessimistic, 0. Optimistic, okay, all of them want to eventually communicate. So it's really this is no longer really an astronomy question, it's a personality index. Are you an optimist or a pessimist? Because it's going to control the answer. Finally, the last number in the Drake equation is the lifetime of the civilization. Shermer, the researcher, basically said, let's look at all the different civilizations that lived on Earth and then measure how long from when they started to when they essentially ended, and average it. So the average length of a civilization on Earth turns out to be about 450 years. Now, it's pointed out that does not include like a civilization that's like the Holy Roman Empire that turned into something else. And so is that all one civilization, or do you just count the Holy Roman Empire by itself and then what came after is separate? So the continuity issue is ignored here, where it's a separate civilization that identifies itself separately. The average length of its life is 450 years. Now, other people argue if you can get past the crisis that we're currently in, if you can get past it and get to a post-scarcity society and solve a lot of these problems permanently, maybe the society could last indefinitely. So it's either really short or it's really, really long. And once again, pessimist, optimist. Carl Sagan would argue it's all about the nuclear weapons. Use them, short. Don't use them, long. All right, so multiply it all together. Of course, there are multiple estimates. If you take all the happy upper range estimates that I just looked up, I multiplied them all together. Here's my math. Now, the number 36 million basically is driven by the fact that I just took all the happy estimates for the L. I just had to make up a number. So I took a big, long number and put it in there. And if I change that number, the answer changes. So it's a big number. Like Frank Drake got 20 million. I got, what was that, 3 million? Okay. So if he was a little more optimistic than me, you get a bigger number. So basically, we'll just say this. It's a lot. If life is automatic and there's lots of planets and, there's the chemistry's right, you automatically get life, and it tends to want to communicate. It doesn't tend to kill itself off. Okay, millions of alien civilizations in the Milky Way. That's what the optimists say.
So you're optimistic is there's millions of millions of intelligent.
Who we could talk to if they wanted to and we wanted to.
It's not just
Right.
bacteria or something. It's
this
something,
is about
something that can
ones we can
communicate.
talk to.
Yeah.
Right. Not just, the thing that bugs me about like Star Trek, lots of things do, but I love Star Trek. It's one of the reasons I'm a scientist. But every planet they go to, it could be a planet of slugs, and somehow they're intelligent slugs. They never find a planet where there's just trees, not intelligent trees, just a bunch of trees. Right? Because that's not a dramatic story. It's interesting and fun to tell. There must be many more of those. I tell myself, they just don't tell us about those. But they exist. They only tell us about the interesting ones where the trees talk and stuff. Anyway, what if you're a pessimist? You put all the lowball numbers in? This is what you get. 1. And I'll confess to cheating. I cheated on my homework because obviously we're here, right? It should be 1 at least, right? So I forced it to be 1 by taking the fraction willing and able to communicate. I manipulated the numbers to make it equal to 1. So, I adjusted the numbers, took that lowball estimate for the 350 years that we got from that researcher Shermer, and I fraction and willing able to communicate, that's an unrealistic number, 437%. That doesn't make any sense. But if I force it to be a big number like that, then I get 1. Since this can't be over 100%, then some of these other numbers have to be off for this number to be 1. And we know it's 1, right? Right? We know it's 1, right? Do we?
So far.
But what if you're really, really, really pessimistic? then you get less than one. But that actually means something. Maybe it means there's only one intelligent civilization for every 150 galaxies or something. So there's a lot of life in the universe that's intelligent, but it's in other galaxies. We're never going to meet it. It's like one in Andromeda, one in M33, and one over here in the Sculptar galaxy. So maybe it's that rare that many galaxies don't have any, and we just happen to live in the lucky ones. So it could be less than one, because this is an estimate for the Milky Way. And if the estimate is less than one, it means, okay, we're it. It's a terrible responsibility to realize we're the only intelligent civilization, and everything the universe knows about itself is with us, a bunch of angry monkeys arguing over who gets more dirt on a little dirt ball. And a few of us do carve out enough time and wealth to allow us the time to consider the bigger questions. And that's all there is. There's nobody else to talk to. We're all alone. It's kind of a sobering thought and kind of depressing a little bit, but it could be, that could be true. It could be true. We don't know yet. Maybe it's just us. But it could be worse. I have evidence. Maybe it's zero. I'll share with you some evidence, and I'm told we're supposed to take a break, so I'll show you the evidence, and we'll take a little break before we get into the interactive part where you have to do something. So what's the evidence I have that this number is zero? Let's see, where is that slide? Here it is. These are quotations from my students. One of the 3 kinds of rock brought back from the moon is asphalt. I was asked in all seriousness a couple of years ago, do we live on the earth or in the earth? Okay. And then I was told on a test question, Kepler is important because he killed Tycho Brahe's moose model in a sword fight. I was talking about the moon landing conspiracy theory, and a 9th grader once asked me, wait, the moon landed on the earth? I don't believe in that. When did that happen? On this year's class, no names, this year's class, I get at the beginning of the year, I give a question list. Give me these 10 answers and ask me something. And I answer the kid. Whatever they ask, I try to answer them. So you're curious enough to ask, I'm going to answer it. One kid asked me, was it possible to live on Pluto before it was destroyed? Because it's not a planet anymore. It must have been destroyed. Yeah? And this exchange happened during a Zoom class where I'm trying to get somebody to draw, in a physics class, a 30-degree angle to draw a ramp problem for a physics problem. I says, use a protractor to measure your 30-degree angle. I don't have a protractor. Okay, download a picture of a protractor and then print it out and you'll have a protractor. I have a printer. I says, okay, take a piece of paper and fold the corner into thirds. Each one will be a 30-degree angle. You can trace it. You'll have a 30-degree angle. You'll make one. I don't have any paper. I said, it doesn't matter if it's, notebook paper. Use a paper towel or an instruction booklet or even a shopping bag. Just fold it into thirds. I don't know how to do thirds. So, at some point you kind of have to surrender and say, yeah, it's a zero. Anyway, this is a good place to take a little break. I will conclude with this one before the next section starts. I did cheat, as I said, I looked it up on Wikipedia. Other people have run their estimates. The lowest estimate I found was 9 times 10 to the 13th, which means essentially we're the only one in the entire universe. The highest estimate I found for the Milky Way is 15 million. So if you're super optimist, you think there's a lot. So it's one thing to estimate how many intelligent alien civilizations exist that might want to talk to us. In the second half of this presentation, we will talk about how many of them can we detect? Have we found any? And what's the status of the search for extraterrestrial intelligence? Have we had any luck? So break time?
Yep, we're going to take a 10-minute break. It's 8:27, so we'll start back at 8:37.
Oh, not that.
All right, testing, 1, 2. I think I turned it back on successfully.
Okay, I've put Jeff back on the other mic. Can the people on Zoom hear him okay? Jeff, can you give a?
Testing, 1, 2, 3. Okay, now we're talking about, well, are we able to talk to them? If there are some alien civilizations willing and able to communicate to us, are they talking to us? Are we trying to listen? So on the small but non-zero chance that there are aliens trying to talk to us, or maybe perhaps talking to each other, have we ever heard a signal? So I'm going to lead with this. The SETI Institute, as you may know, is an organization, a think tank dedicated to the search for extraterrestrial intelligence. Started out as a NASA project, and then some senator found out we were spending money on aliens. So they promptly canceled all of the funding suddenly. So the SETI Institute was reborn as a nonprofit organization that operates on donations. One of their donations they got, several $1 million, from Paul Allen, recently deceased, I think, who was a founder of Microsoft. And Paul Allen gave them, I think, maybe over $100 million, if I'm not mistaken, to establish a network of radio telescope dishes to look for aliens. This is an artist's conception of what the array would look like when it's completed. They've started building it. It's already in use, but there aren't that many dishes in it. This is located in a place called Hat Creek, California. It's a fairly radio quiet area. All the dishes are slaved together. They can move independently, or they can all move at the same target at their discretion. So the SETI Institute is not just listening for alien signals, although they do dedicate some effort to doing that. They're also doing anything related to exoplanet research to identify planets that potentially have life. So there's a lot of research going on there that you might consider to be more mainstream, ordinary, legitimate astronomy research to identify the candidates for planets that might have life, the conditions of biology research about what are the origins of life. They sponsor research projects. They have a staff of astronomers and researchers. They do outreach and things like that. So anything related, not just for the search for little green men and radio signals, but anything related to exoplanets and life, they might have their hand in it or have somebody at a conference making a presentation or contributing to a research paper, even with astronomers who are not directly interested in the search for extraterrestrial life. So they're trying to legitimize the search for alien and intelligent life. And this is one of their efforts. They do a lot of different things. So I heard about this. And then when I was in graduate school, I was really fortunate. I had a fellowship to go to the University of Arizona. And I got to go up, I did some of my childhood dreams. I got to go up on a mountain and use the giant telescopes like I'd always wanted to do. I got to push the buttons and take some pictures. I've gotten to use space probes. I've met relatively famous people. One time, let's see if I can remember, I got to talk to Carl Sagan for about 5 minutes. I got Neil deGrasse Tyson punched me in the shoulder when I said something he liked. And I met Bill Nye the Science Guy, and I found out he really does talk like that all the time. That's just how he talks. And, I've had a lot of experience because of my stature as a teacher, not because I'm particularly important, but I just get to be put in the right place at the right time and get lucky. And so one of my graduate school classes, I went to school with a lady named Edna, who subsequently I discovered became the director of education and outreach for the SETI Institute. So I was like, I got a connection. How can I use this? I says, okay, Facebook came out, and hi, Edna, remember me? I was your classmate in grad school. And she says, yes, of course I remember you. We did study sessions occasionally. I said, yeah, we did. So I hear you're working for the SETI Institute. Now, how would you think about coming out to Antioch and talking to my high school kids, somebody who actually works for the SETI Institute? I think it may carry a lot more weight than just me, some schmuck here, has never actually done the research. Would you consider coming out here? And she says, no. No, I don't want to do that. But she said, I'll do you one better. My boss, she says, who's the chief scientist for the SETI Institute, has to come out to Antioch all the time. I'm like, why? And he says, I'm sure I could talk him into stopping by your classroom. So I was like, okay, that's awesome. So Edna told me why Dr. Seth Shostak comes to Antioch. It turns out that the dishes they're building for the SETI Institute have special antennas that are manufactured by a company called Minex Engineering, which is in Antioch. So there's a local connection. We actually went on a tour. It's a really small company. The entire company and the factory floor and the place where they do all the electronics testing is smaller than this room. It's in a little warehouse building off of Wilbur Avenue, if you know where that is. There's a soccer field next to it, and out behind this little nondescript sort of industrial-looking building, there's a satellite dish in the backyard. It's the prototype for all the dishes that they put in Hat Creek. That's what it looks like. He has to come to Antioch to have meetings with the engineering company. Is building all of his antenna assemblies for the SETI Institute's Search for Extraterrestrial Life. He goes right by the exit where my school is, so she talked him into stopping by on one of his many trips he had to make out there. He came by, that's my classroom. So this is one of those guys you see in the Nova specials, and they say Seth Shostak, alien expert, and he's got a little crayon with his name on it, and he says a few words, you know, and they keep quoting him in the movie. He's been on TV any number of times. His name keeps popping. I learned, for example, that I was mispronouncing his name. I introduced him as Dr. Seth Shostak, and then he says, yes, my name is Shostak. And, oh, sorry. But anyway, nice guy. And he made a speech. I took notes. He said, I crammed every astronomy student I have into my little classroom and moved all the stuff out of the way. I had like 150 kids in there all jammed together. And he came to give a speech, and the high school TV class filmed him, and they won some award for interviewing this famous person, and they turned it into a contest entry and won some award just because he happened to be in the building. So it's pretty cool to get somebody like that, sort of like the people you guys invite every month came to my high school class. And here's my notes. Again, this was a while ago, but he said at the time he gave the speech, he was confident that aliens would be discovered within 25 years. And I'm like, well, how do you make such a claim like that? And his answer was, if aliens exist and they're talking to each other with radios, they're not talking to us. They're talking to each other. And we happen to be in the area where we could hear the signal. The problem is there are many millions of radio frequencies that exist, and we could be listening to the wrong frequency in the wrong direction. But if you extrapolate the rate at which our radio technology is growing, he said, within 25 years, and this was 10 years ago when he said it, within 25 years, we'll be able to listen to every possible radio frequency in every possible direction all at the same time. Therefore, if there is a signal to be found, he said, we will hear it sometime in the next 25 years. So either there's no signal, they don't use radio, or they don't want to talk to us. We will know that. One of those things will be true, and we'll know it within 25 years. Or we'll hear a signal, and we won't know anything about what it means. We probably won't be able to interpret it at all. Or we'll be able to verify it's coming from deep space, and we didn't make it. We have no idea what the content of the signal means. It's probably not encoded for us to be able to figure out some secret Rosetta Stone of information and decode it. But we'll know that it's from an alien, and it's not about us more than likely. So he made that bold claim, I think, and that's his logic. He thinks in all the movies, they say the government knows the aliens are here. They're keeping it secret to avoid panic. He says, we've been watching alien movies for 50 years. Everybody is not going to be surprised and frightened and shocked. They're going to go like this. They're going to say, oh yeah, I heard there's aliens. That's pretty cool. That's exactly what he expects to happen, It'll last about 5 minutes. I heard there's aliens. Well, okay, cool. What is Christina Aguilera doing tonight? Okay. So, he doesn't think there'll be mass panic. It's kind of like, of course there's aliens. What do you mean? You just found out. Of course there is. I've always thought so. And then his estimate of the Drake equation, he thinks he's an optimist. He thinks there's millions of Earth-like worlds, enough people to talk to that it's worth Paul Allen's money to spend some time listening just to check. And I have to tell you what he told me and what Edna told me is that we've been listening for a few years now and haven't picked up anything that we can report to you as unequivocally away from deep space. You might know the story of the discovery of pulsars. So when pulsars were discovered, it was briefly thought that they were alien signals, but nobody said anything out loud, right? Because it was a repeating radio signal, it's very regular. But the theory caught up with the observation and realized it's a spinning neutron star, so we now know that pulsars are not aliens. So there are no signals, but what we have, you know, people looking. The SETI Institute was started by Jill Tarter. I met her once and got her to sign a book. So again, yeah. They have a video there telling about their work. I'm sure it's easy to find, so you probably can find that on your own. Now we have, in an attempt to contact aliens, sent messages to deep space a few times of various kinds. Here's a short list. It's probably not comprehensive, but things that we've sent out into space, hoping the aliens will hear us and maybe perhaps reply. We sent messages on the Pioneer and Voyager space probes. We did a thing as a stunt called Project Ozma in the 60s. We've sent messages, that's spelled wrong. The Arecibo radio dish was used to send signals to other systems, and perhaps we've sent accidental signals, as in the novel Contact. The first TV signal we sent into space with enough power to penetrate the atmosphere was a video of Adolf Hitler making a speech at the 1930 Olympics, which is actually probably true. That's probably a true statement. That's their introduction to us, and the last video they will get is, well, you know, it's just happening now. So Project Ozma was done by Frank Drake and other people in 1960 at Green Bank, West Virginia, with that big dish they had there before it fell apart. They actually aimed at two stars, Tau Ceti and Epsilon Eridani, using the 21 centimeter wavelength that can penetrate through dark nebulas and stuff. They sent signals for 150 hours. Those stars are close enough to us that we would have heard a reply if anybody wanted to reply. We've never heard a reply. But, you know, it's just, let's just try it and see what happens. Send a signal and wait and hear, and we listened for years and never heard anything in reply. So either there are no aliens there or they don't want to talk to us. There's only a few logical possibilities there. We send a plaque out to on Pioneer 10. You know, I do teach high school, and I don't want my class distracted for like 25 minutes. So, you know, just in case you've never seen this before, the figure behind the people is a diagram of the space probe and how big it is, to give you a sense how big a person is. The lines spreading out are binarily encoded distances to nearby pulsars. The idea being, if you could identify a few pulsars in our neighborhood and their pulsation period, they tend to be pretty stable over long periods of time. So that would give you a map. The center of it is the Earth. So not only do we tell them that we are here, we gave them directions on how to find us. And then there's a diagram of our solar system, and I do want to point out that back in those days, they still counted Pluto as a planet. So they're showing that the space probe came from the third rock from the sun. Perhaps if the aliens are at the right distance from us, they can watch the TV show and know what that means. On the Voyager space probe, we sent a more sophisticated thing. We sent the same map, you might notice. It's pretty much the same map. On the flip side of that disk, there's a phonograph album, and there's some IKEA directions on how to build a record player. If you play the record, it has hundreds of samples of music and people speaking, saying hello in lots of languages. I think the president makes a little speech. There's lots of music samples. I captured one. I bought a reproduction of the album, so I could hear all the stuff that's on the album. So I picked one for you to listen to. This is on the album that aliens will listen to if they intercept the record. Dance party, everybody. So there's a whole bunch of other stuff, including some obscure stuff. There's early rap. There's some, Gregorian chants, and all kinds of stuff. And there's also some sounds of various animals and things. So it's kind of interesting to listen to. So we sent that out. Now, honestly, Voyager 2 is now about 3.5 times farther away than Pluto. It's going to be about 50,000 years before it ever gets to another solar system. So I think it's much more likely that in the distant future we will decide we have more advanced spaceships, assuming we're still here. We go out and find Voyager 2 and bring it back and put it in a museum before aliens will find it. But, you know, it's a symbolic gesture. It's kind of an optimistic, hopeful thing. Maybe they'll find it and maybe they'll like us, you know. And they'll come back and looking for more music and want our top 40. So we sent that out, but don't really expect a response. Let's see.
Might they be looking for a Tesla Roadster as well? Or asteroid? I apologize.
Got any more cars out there? Okay, so this was a signal that was sent out once by the big dish in Puerto Rico to M13, which is, you know, thousands and thousands of light years away. So there's no way we'd get a reply. But it's supposed to be an encoded message that an alien civilization might have a chance of decoding without knowing any English. So I think it's kind of obscure. A lot of it is, but I know a few of these symbols. The blue thing in the middle, by the way, it is not colored. It's sent out as ones and zeros. So if you printed it out as a picture, it's black and white. They colored it for us. So the blue thing, squiggle, is supposed to represent DNA. Obviously, the red figure is a person. The yellow dots under the person is the solar system, and you see the third dot, the third rock from the sun is sticking up, because that's where we are. And then the radio dish that sent the signals at the bottom, I don't know what the other symbols are. Somebody, you can look it up. But the idea was an alien civilization would, first of all, have to realize it's a picture, because to them it's just going to be beep, boop, beep, boop, beep, 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 boop, beep, right? And they'll realize that maybe it's a picture when they realize it's a product of two prime numbers. So they'll make a grid out of it, and if they color in the beeps and not the boops, they, oh, there's a picture. And maybe they'd have some chance of figuring out what part of it meant. And of course, we sent it so far away, it'll be thousands of years before we hear a reply. It was really done as a, you know, a stunt, not really expecting a reply. And then there's this. Maybe we're just eavesdropping, you know, like they're talking to each other, but not to us, and we can listen in. That's what the SETI Institute's project's about. Along the way, somebody decided, what if we just took every radio telescope dish signal in the world, people who are doing real radio astronomy, and we just listen in case they accidentally heard aliens. So a project called SETI at Home was started. It was through the 2000s. You could get a screensaver. It would run in the background on your computer, and it would download the radio telescope data from other research that's not about SETI, and then process it listening for signals when your computer was idle, using electricity from your house for free. So people would sign up and it would download a batch and would scan through it and send the results back. And they did that for well over 10 years. I didn't find anything. Zippo, that didn't work. It was, eventually they got depressed and quit, ran out of funding. And it's okay, we did a whole bunch of them. We did thousands and thousands of files, didn't find anything, and the funding ran out. So that project is over. And then another one called Zooniverse did a similar thing. Zooniverse is a still active project. It has dozens of citizen science projects, not all astronomy. One of the interesting ones was, can you get old people who can still read cursive to read the ship captain's logs to get the weather reports from the 1600s for climate studies? You know, so they get volunteers to read the logbooks and type in the numbers. And you know, they do all kinds of citizen science projects where like people like us can contribute. And one of them was to classify galaxies. One of them was to look for exoplanet events in Kepler data. And you know, that project went its full course. They did all they could do with it. Some people contributed to the discovery of a few exoplanets, but that project has ended. And searching for signals in the radio telescope data was part of Zooniverse too, but they too have abandoned the project and saying, well, this is now archived. We're not actively pursuing it, but there's still like a historical page there to look at. So both of these were interesting attempts, but neither one found anything, and then neither one is currently processing new data at this point. There have been a few intriguing possibilities that have popped up. The thing about science is if you're going to claim there's aliens, you need strong evidence. And you can't just see it once, you have to repeat it. Honestly, I'm just going to tell you, we don't have that. Okay, it doesn't exist. But there have been, like a UFO sighting you can't explain, there's been a few odds and ends that have popped up from time to time. There was a kerfluffle about 2 years ago where the radio signals from Alpha Centauri were discovered, and people thought, oh, this is it. And then It lasted about 6 or 7 months, and then they found out it was some kind of electronic glitch in the radio, and it was from Earth. So that one fizzled. Another one is from 1977, the so-called WOW signal. And I have no idea how to read this data, but they circled these numbers here represents a really strong signal from outer space. And it was like a coherent radio signal, but there's no information in it. So people kept looking at it, and they kept watching it for years and years, and they never got another one. So the WOW signal is, as of today, still unexplained. We don't know what it was. Yes, sir?
A couple months ago on Rob's YouTube channel, he discussed a paper that explained it.
And there have been a few attempts like that. I don't think it's percolated down to what you might say the textbook level, where we're writing about a solution in a book. But yeah, I think I heard that too. I don't know what the explanation was, but yeah, I remember reading an article about it. I just have not remembered what it said. So eventually it'll, I think it'll be like the Alpha Centauri thing. Like, okay, we have a probable explanation, and whatever it is, it's not aliens.
I don't remember the details of the explanation, but it was not an equipment problem.
Yeah.
It was they found another occurrence.
A natural
source, and they understand what's going on.
That's what I
they
remember
think.
too.
Yeah.
And then you might remember from 2020, the scientist named Avi Loeb. We had a extrasolar asteroid come through on a hyperbolic orbit. So it's not a member of the solar system. It came from somewhere else. And it whipped around the sun and shot off in a new direction, never to return. We did not get a photograph of it. That is a drawing. We did radar it. From the radar data, we got the shape of it, which is really weird for an asteroid. If you look at our asteroids, they're all shaped like potatoes, sometimes like peanuts. It turns out many asteroids are double lobed with a little neck between them. The other ones that are single objects look like rounded potatoes. So we have an asteroid here that's long and skinny, the details of which are imagined here, but the shape of it is generally what the radar signal revealed. So Professor Loeb has come to the conclusion it's an unnatural shape, and it was probably an alien spacecraft flying through our solar system like Rendezvous with Rama, if you know that old book. It's not paying any attention to us at all, but it's just a way stop on its way somewhere else. By the way, that's going to be a movie soon, Rendezvous with Rama. I don't know if it'll be any good, but we'll see. Anyway, so he's the big champion for this. He's the one who keeps promoting it, and he really hasn't talked anybody else into buying into it. So it's an intriguing object. We're not going to be able to study it again. It's leaving the solar system. It'll never be close to us again. All we got is the data we got. But he has made a number of arguments about how, for this reason and this reason and this reason, it's probably an alien spacecraft. But he's not succeeded in convincing the rest of us. So we have these little hints and suggestions, mostly, I think, honestly, wishful thinking. Remember, if it's science, you got to be able to do it more than once. You got to be able to back it up and, observe it more than once and get critical people to look at it and have peer review of your studies. And if you just get a thing that happens one time only, it's difficult to make your case. And these are the best stories. That's the good stuff. Everything else is worse. So I think that if the alien signal was discovered and we really knew about it, it would be really hard to keep it secret. You know how you guys are amateur astronomers with telescopes? There are amateur radio astronomers all over the world. If a signal could be picked up by an amateur, no government could keep it secret. It would be around the world almost instantaneously. And there'd be some country that doesn't like us where the people would talk and someone else would back them up and somebody in their backyard would be able to detect it too. And the next thing you know, we'd all know. But that has not happened. And of course, I mentioned this earlier, Stephen Hawking thinks maybe we shouldn't be doing this at all. His point is, in our own history, every time an advanced civilization has met a primitive one, the primitive one has lost badly. They've essentially been wiped out. So if a civilization far more advanced than us met us, that bad things would happen to us that would only be a minor inconvenience to them, and it wouldn't be worth their time to even try to help us. Maybe that would be a bad thing. And a person could imagine such a thing. So one of his messages was before he died, yeah, maybe we should not be transmitting all this stuff into space. Maybe not a good idea. So I mention it. There's probably no way we're ever going to stop transmitting data over the open airwaves, but that was his point of view about that. So here we arrive at basically the same place where we started. What do we know now that we didn't know before? Well, there are probably lots of aliens. We don't know for sure. They've probably not been here. So after all of this discussion, I don't think I've added a whole lot more to your body of answers than I had when we started. But at least, you know, there are people who are smarter than me who are looking for it. Maybe someday, like the exoplanet, we will know more. And I suspect that, again, some of these younger people will live to see the day that we can confirm that there's life on another planet. We're probably not going to be able to talk to it, but at least we know that something alive is somewhere else. It's a prediction, and I can't give you a percentage on it, but I didn't think we could ever find exoplanets either. So maybe the optimist in me says someday they'll remember this day and say, hey, that old guy once said that we'll find a life way back in the early 2000s. It was, yeah. They'll remember and think about me back then. Now it's time for the interactive activity part, because there's always one, right? This is an old activity, about, I don't know, 15, 20 years old, from the Astronomical Society of the Pacific. And here's the deal. We heard a signal, and we don't know what it means. So I'm going to play it for you. Now, the signal is only going to get played twice. I'm going to play it twice so we know it wasn't a fluke. And your mission is to receive the signal, record it in some way, and then figure out what it means. The first pass, I want you to just listen to it and think, well, how am I going to write this down? And the second pass, you got to figure out a way to record it so that you can then analyze it as a group. Okay? The first person who has the right answer, there's a message in this alien signal. There's a message hinted in it. The first person who delivers the message to me will get one of these fine booklets, which is called The Scale of the Universe. It's, if you've ever seen the Powers of 10 video, it's how to make one out of a flip book for yourself, right? It's a nice little book done by the TOPS people who do a lot of paper pencil cutting things. So you just follow the directions, cut out the pages, make a little flip book, and you're making the Powers of 10 video by hand. If I am going to retire, I got to get rid of these things. So first person that gets it gets one. And then I want to also make the point that if somebody did hear an alien signal and could interpret it, they are probably not going to keep it to themselves. So if that first person who figures it out tells other people can get the book too. So here's your first pass. Listen to the signal, record it or not, but you'll get a second chance. So this is what it sounds like. Oh my gosh, there's an alien signal. Everybody point your radio telescopes and listen to see if it comes back again. While we're waiting for the repeat, if you need a pencil, I have pencils. If you want paper, I have paper. So if you happen to have those things yourself, the goal is write that down any way you see fit and then talk amongst yourselves. Can you figure out what the signal means? I expect all of you to do this. You kids in the back, come on, get this paper. Come here. Come here. Come here. Over here. Come here. Come here. Come on up. Oh, that's all you need, pencils and paper. Come on. So task 1, record the signal. Task 2, turn it into a message somehow. I gave you a hint earlier about how it works. You can have one. I'm funnier when I'm here. Okay. More pencils available if you want them. We're listening with our radio telescopes. Maybe the alien signal will repeat itself. Figure out how you want to record it, capture the data, and then you can worry about like turning it into a message, however you think you can do that. But I will tell you, I did give you a hint earlier in the presentation about how to do it. There's been a hint presented to you already. All right, here comes the signal again. This time, everybody around the world is ready. We're all going to record it. So if the signal doesn't repeat again, we'll have a record of it. Okay, ready? And go. Okay, in 3 minutes, I will give you a hint. But you got 3 minutes, no clues. In 3 minutes, you get a hint.
It would just go right past me. I would never know if there were aliens trying to communicate with me.
Okay, 3 minutes and 5 seconds. Okay, here's your first clue. I'll give you 2 clues. Clue number 1, Each different sound you heard is a bit of information, like a 1 or a 0. Step 1 is to count the bits. You need to know the total number of bits. The other half of the clue is the result is a picture. You're trying to make a picture out of the bits. The information, the message is hidden in a picture. So count the bits and then try to make it into a picture. You'll get another clue in 2 minutes.
Which are the bits?
Hmm?
Which are the bits?
Each sound is 1 bit. There's 2 different bits, a 0 and a 1. So,
Most of them are.
right, every sound you heard is a bit. Would anybody like to care to share the total number of bits so everyone else can check and see if they got them all? How many bits are there? How many? I have a nomination for 24. Anybody second that? To show the 24 bits in the picture. That's a clue. Ladies and gentlemen, we have a winner. Someone's figured out the message. But here's the trick. If one person in the world heard the alien message and understood it, their mission now is to tell other people how to do it. So when they bring me up their picture, they get a book too. So one person tells 2, 2 tells 4, and next thing you know, everybody will know the answer. She's going to tell a couple of people. You pick a couple of people, show them. Then when you find out, you show other people. Soon we will all know what the message says. Bring me your picture, you get a book. You're supposed to figure that out.
I did not. This is online.
So reply to them. That's for you to figure out.
Hey, Donna, that's for you.
So here's my first problem. That's the part I don't get.
Did you have the test before? Did you? Did you have the test before?
She's not done this before. Okay, we already have the answer. It's spreading. It's going to start spreading through the room, so I don't need to give any more clues. It's a grid. You're going to make a grid out of it. How wide is your grid? So you make a grid 6 by 4 and fill in the dots. See what you get. It's a 6 by 4 grid. And as soon as you have the picture, I give you a book. You know the answer, sir. Here's your book. Well, that's the idea. As soon as one person knows, the world will know, will it not? It's a difficult secret to keep. So when you think you have the answer, come up and say it to me, and I will give you a book. She'll show it to you. In the interest of the lateness of the hour, I will take a verbal answer. Show them what to say. Come on up. Say the word to me. You get your book. Guess what, ladies and gentlemen? That's the end of the presentation. You've decoded your alien message. Say the right word. What does the message say? Here you go, sir. What does the message say? There you go. Oh, these are free too. Help yourself to those. Anybody else want one? Come up and say the magic word, or I'll come to you. Eat your. Yeah. I saw that movie too. Say the word. You want one? Say the word. Hi. There you go. Okay. Anybody else want one? Say the magic word. What's the magic word? Hi. There you go. Magic word. The message says hi. Turns out they just want to say hi to us. Okay. I got a bunch of these. You want one? Come up and get one. Have a great evening. Thanks for coming by. Good job.
Hi.
There you go.
Thank you so much.
And those black ones are free too. Grab those.
All right, in the, because we're short on time, we're just going to go ahead and end the meeting.
Oh, thank you.
I do have a quick announcement from Renee Gandolfi about the Yosemite Star Party. Let's see if I can find it.
Magic word is correct. I don't need this anymore, so I'm going to turn it off.
Okay, Yosemite Star Party is going to be July 31st to August 3rd of this year, if you guys want to put it on your calendars. He'll give you more information in April.